Residing at the intersections of the large-scale structure of the universe's cosmic web, galaxy clusters are some of the largest gravitational-bound objects in the universe. Dark matter accounts for roughly 80% of the mass of a galaxy cluster, with baryonic matter accounting for the remaining 20%. Scientists recently discovered intriguing radio structures in the heart of an enormous cluster of galaxies 800 million light-years away. What exactly are these structures, and how did scientists discover them? Join us in today's video as we go over some of the most recent surprising scientific discoveries. The James Webb Space Telescope outperforms all previous telescopes in measuring faraway galaxies. The James Webb Space Telescope was launched in December of 2021 with a 6-month mission to return with the most up-to-date detailed pictures of our universe. The photographs were revealed to the world 6 months later, in July 2022. Data from the James Webb Space Telescope is critical for a variety of reasons. One of the reasons this data is so important to scientists seeking to figure out how the universe's early galaxy formed, scientists can achieve the most accurate stellar mass estimates from some of the most distant galaxies we've ever studied by using the telescope's near-infrared sensor. This new data is significantly more accurate than any other piece of information gathered thus far. Stellar mass, or the mass of a star, is an important statistic that can help astronomers understand how a galaxy arose and evolved. In fact, it is one of the most crucial pieces of information scientists can use to understand the formation and evolution of a galaxy. During the lifetime of a galaxy, stars are added as dust and gas transform. The stellar mass of an object estimates the total number of stars in the galaxy. This allows scientists to properly follow the evolution of the galaxy, and observing distant galaxies allows them to see galaxies in the creation process, which will help them understand our universe on a larger scale. This is just one of the many reasons why the new discoveries from the James Webb Space Telescope will be crucial as scientists learn more about the formation of our universe and the galaxies within it. For millennia, humans have been fascinated by stars, and over the years we have developed technology to assist us grasp these great unknowns. Nonetheless, there appears to be so much more to explore beyond our atmosphere. Astronomers are still looking for answers and have discovered some unusual radio emissions in a faraway galaxy cluster. A galaxy cluster is the largest massive object in the cosmos that maintains its stability by gravity alone. They are largely made up of dark matter, but they also have a lot of hot plasma and hundreds to thousands of separate galaxies crowded together, as the name suggests. Astronomers recently discovered uncommon radio objects within a galaxy cluster deep within our universe. A radio halo, a radio relic, and a fossil radio emission are among the radio objects. While most galaxy clusters feature some form of radio object, the ones discovered in Able 3266 were unique. Scientists discovered that these radio objects do not conform to known ideas regarding the genesis and features of radio objects, leading them to call those theories into question. When one galaxy cluster collides with another, scientists believe radio halos, remnants, and fossils are formed. When they collide, energy is transmitted into the heated plasma that forms galaxy clusters, causing radio emissions. These emissions might come in a range of shapes and sizes. Radio relics, for example, are arc-shaped and can be found on the outside borders of a cluster. At the same time, halos are more concentrated in the cluster's center. The fossils are unique. When a supermassive black hole dies near the heart of a radio galaxy, fossil radio emissions are produced. Able 3266, located approximately 800 million light-years away, is a highly dynamic colliding system. Scientists were first perplexed because no relics or halos were discovered on Able 3266, a cluster that was supposed to contain these radio artifacts. Scientists used the ASCAP radio telescope and the Australia Telescope Compact Array to gain a clearer look at Able 3266. The data assisted scientists in identifying discrepancies in the energy emissions emitted by the galaxy cluster. They used the data to examine the newly discovered radio objects more closely and determined that they do not have the same properties as other radio objects. While there are thousands of clusters, Dr. Wernstrom claims that surprisingly few objects like those in Able 3266 have been discovered. They are basically just hard to detect. She claimed that only new telescopes could view this cluster in such detail. We would never have seen this without ASCAP. The telescope detects radio emissions, the longest wavelength of energy in the sky, using a network of 36 antennas. By looking in the radio, you see kind of different physics than when you look in the other wavelengths, Dr. Wernstrom explained. It is also significantly more sensitive and can see more detail than smaller radio telescopes since it uses many antennas stretched across 6 kilometers. According to Dr. Wernstrom, the discoveries in this cluster were only the beginning of what scientists would discover using ASCAP. The telescope will study the whole southern sky during the next 5 years. We're going to see a lot more of this kind of stuff. This new discovery alters scientists' understanding of radio objects, galaxy clusters, and their interactions with the universe. This was not, however, the only recent astronomical discovery. Astronomers at MIT and other universities in Canada and the United States have discovered a peculiar and persistent radio signal from a distant galaxy that appears to flash with amazing frequency. The signal is classified as a rapid radio burst, or FRB, a burst of radio waves of uncertain astrophysical origin that normally lasts only a few milliseconds. This novel signal, on the other hand, lasts up to 3 seconds, or 1,000 times longer than the average FRB. The scientists discovered bursts of radio waves that repeat every 0.2 seconds in a clear periodic rhythm, akin to a beating heart, within this window. The signal has been designated FRB 201912221A by the researchers, and it is now the longest-lasting FRB with the clearest periodic pattern recorded to date. The signal's origin is in a faraway galaxy billions of light-years away from Earth. The source of the signal is unknown, but astronomers believe it could be a radio pulsar or a magnetar, both of which are forms of neutron stars, incredibly dense, fast-spinning collapsed cores of huge stars. The researchers aim to find other periodic signals from this source, which might subsequently be utilized as an astrophysical clock. The frequency of the bursts, for example, and how it changes as the source moves away from Earth may be used to calculate the rate at which the universe is expanding. In another significant step forward, researchers have discovered and mapped out more than 1 million galaxies that were previously unknown. Due to the immense size and brightness of our neighboring Magellanic Clouds, these galaxies are normally invisible. The Magellanic Clouds are dwarf galaxies that are close to our own Milky Way galaxy. The clouds are so dazzling and huge that they can be seen with the bare eye. Their brightness and size also obstructed scientists' views of some more distant galaxies until a group of astronomers discovered a means to peek beyond the Magellanic Clouds and map out around 1 million distant and hidden galaxies. Jessica Craig, an astronomer from the University of Kiel and a part of the map-building team, describes the significance of the new map depicting these hidden galaxies. The Magellanic Clouds are lovely galactic companions, but they obscure our vision of objects further off. Our work is assisting in overcoming this and, in the process, filling in the gaps in our maps of the universe. Because these galaxies are difficult to view, the map-making team first sought to picture gaps between stars within the galaxies using Chile's Visual and Infrared Survey Telescope for astronomy. Still, the Magellanic Clouds made it impossible to view the hidden galaxies, which appeared redder and fainter than they actually were due to the Magellanic Cloud effect. To compensate for the lack of clarity, the scientists employed the Galactic Australian Square Kilometre Array Pathfinder Survey, or GASCAP, which can see through the dust between Earth and distant galaxies. Scientists were able to begin building a map of the Magellanic Clouds with the help of GASCAP, including detailed placements of gas and dust within the clouds. This map enabled them to account for the faintness and reddening of distant galaxies. They used data from the Gaia Observatory to map out stars to discriminate between the enormous number of light sources in their photographs. Stars move over time, while galaxies remain relatively stationary. By tracking the movement in this location over time, they were able to identify whether the light source they were looking at was a nearby star or a distant galaxy. They examined the reddening of each light source to confirm their findings and ensure that they had accurately classified each light source. The farther away the source, the redder the light appears. Therefore, galaxies would have longer wavelengths of visible light and appear redder. Finally, scientists were able to create a 3D map of faraway galaxies using artificial intelligence, resulting in an estimated 1 million extra galaxies mapped in our universe as a result of these astronomers' exact and meticulous work. Each of these remarkable findings was the result of years of hard work, and each one brings us a step closer to comprehending the region of space that lies beyond our planet. They are a long way from Galileo's observations of the universe, but each of these discoveries was critical in getting astronomers to where they are now, and these latest discoveries will take us to the next major discovery. But what are your thoughts on these latest discoveries? Tell us in the comments section.